Hi everyone. In this video, we'll go through theory of indices, laws of indices, and also go through 1 marker and 2 marker problems. This is an important concept in mathematics. Theory of indices. Indices is also called as exponent or power, right? Indices, exponent, power all mean the same. Now, let's say that A is any real number. A is any real number. N is any non-zero positive integer. Non-zero positive integer, right? Then the way we write an index is like this: a to the power n. Basically, you write number here, and on the top you write another non-zero number, and this n is called as index. This n is called as index, and this a is called as base. Okay, this n can be called as index or power or exponent. All mean the same. So the way we'll have to call this out is a to the power n. A to the power n. For example, if I have 2 and power as 3, I can read it as 2 to the power 3, 3 to the power 2, 4 to the power 5, 4 to the power 5, 3 to the power 2. So this is the way we'll have to read this out. What does a to the power n mean, first of all, right? What is this concept about? So say take for example 2, right? And you write 3 as a power or 3 as the index, right? What does this mean? It means if I say 2 to the power 3, it means write 2 3 times. Write 2 3 times. This is what is 2 to the power 3 means. If I write, take an example, say like this, 4 to the power 5. This means I have to write 4 5 times, like this, right? So this is a shorter way of telling that you have to multiply 2 3 times, multiply 4 5 times. Let's say you have 9. I'll write it like this: 9 into 9 into 9 into 9 into 9. So I've written this. How many times? 1, 2, 3, 4, 5, 6. Now how do I write in the index form? How do I write in the index form? It's nothing but 9. How many times? 6 times. 9 to the power 6. Let's take another example. Say 6. 6 I will write it 4 times. 6 I've written 4 times. I've multiplied 6 4 times. So how should I write in the index form? I should write it as 6 to the power 4. 1, 2, 3, 4. 6 to the power 4. Now there are a few laws. Right, for all these indices. Simple laws, right? The first law states that if there are two positive integers, m and n, and there is a non-zero real number a, then a to the power m into a to the power n is a to the power m plus n. Basically, we add these powers. We add these indices, right? If you have something like this, you have to add the indices, which is m plus n. So let's take an example, right? Let's say instead of a we have 2, instead of m we have 3, then 2 to the power, instead of n we will write 5. So let's take this example, right? Here instead of a we have put 2, instead of m we have put 3, instead of n we have put 5. So let me write m is equal to 3, n is equal to 5, and a is equal to 2 in this example, right? Now what does this mean? What does 2 to the power 3 mean? You have to write 2 3 times. So let's write it 3 times, right? And then there is an into here, okay? Then we'll put 2 to the power 5. That is 2 into 5 times, right? So this is 5 times. We multiply 2 5 times, and here we multiply 3 times. When you calculate, it's going to be 2 into 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 2. When you calculate, right? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8 times, right? This is going to be 8 times. Now what is 8? What is 8? 8 is nothing but 3 plus 5. 8 is nothing but 3 plus 5. So basically this means that 2 to the power 3 plus 5, which is 2 to the power 8. So instead of multiplying 2 so many times, I can simply say 2 to the power 8. And how do I say 2 to the power 8? By adding these powers, 3 and 5. So this is a very important concept frequently used in mathematics. Basically, if you have same base, that is same number 2, if you have the same base, then you can add the powers. Let's take another example. Say we take 5 square into 5 cube. If you have something like this, then what is the answer? It's going to be 5 to the power 2 plus 3. Add the power, 5 to the power 5. So this is how we represent in the indices form. The second law states that See, in the first law, it was multiplication. First law was you have multiplication here. The second law is about division. The second law is about division. So if you have a to the power m by a to the power n, then you will have to subtract the powers. So when it was multiplication, when it was like this, right, you had to add the powers. But when it is division, right, here it is multiplication, you add the powers. Here it is division, you subtract the powers. Like this, m minus n. So we can prove this using an example. So we have two cases here. One is when m is greater than n, and one is when n is greater than m, right? When m is greater than n, it's going to be a to the power m minus n. When n is greater than m, it's going to be 1 by a to the power n minus m. See, we can prove this using an example. Let's assume that m is greater than n. Let's take same example, 2 to the power 5 and 2 to the power 3, right? This is m and this is n and this is a, right? Instead of a, we put 2. Now, 2 to the power 5 means what? It's 2 into 5 times, correct? Next one, 2 to the power 3. 2 to the power 3 means 3 times. So now, we can cancel this. We can cancel this 2 and 2, 2 and 2, 2 and 2. What we are left with? We are left 2 times. We have left with 2 times. Now, we can also say, instead of 2, we can write it as 5 minus 3. 5 minus 3, right? 5 minus 3 is 2 square. 2 to the power 2, right? So, this is what is mentioned here in this law. That if you have a to the power m by a to the power n, then we can write it as a to the power m minus n. A to the power m minus n. That is 2 to the power 5 minus 3. This is case 1. Now, what does case 2 say? Case 2 is n greater than m. N greater than m. So, let's choose m. Let m be 3, right? Let m be 3 and n be 5. Let's reverse it, right? Right? Now, n is greater than m, right? Now, I'll write this 3 times. 2 into 2, 3 times. And here I should write 5 times. Now, if I cancel, what am I left with? I'm left with 1 by 2 to the power 2. This is what I'm left with. What does this mean? This is 1 by 2 to the power n minus m. That is 5 minus 3. 5 is n and 3 is m. So 5 minus 3, nothing but n minus m, right? We assume that n is equal to 5 and m is equal to 3. Now let's go with the third law. Third law states that if you have something like this, a to the power m and n. So basically there are two powers for the same base. For the same base, there are two powers like this. Then it's nothing but you can write it like this, a to the power m into n. So we can prove this again using an example, right? Instead of a, we'll take 2. Instead of m, we'll take 3. Instead of n, we'll take 2, right? We call this as, let's say, m is equal to 3, n is equal to 2, right? Now, how would you write 2 to the power 3? You'll write it as 2 into 3 times, right? 2 into 2 into 2. And then we'll write this 2 here. Now, what does this mean? This entire thing you'll have to write 2 times, right? Entire thing you'll have to write 2 times. 2 into 2 into 2 into 2 times you'll have to write. Because the power is 2. Now, what does this mean? This is nothing but I can write this 2 6 times instead, right? I can write it 6 times. Now, what is this? This is nothing but 2 to the power 6 because you've written 2 6 times. Now, what is 6? How did we get 6? Nothing but 2 into 2 to the power 3 into 2. 3 into 2. That is nothing but m into n, right? 2 to the power m into n. So, basically, a to the power m, n is equal to, you can write it as a to the power m into n. There are two important notes that we'll have to always remember, very frequently used. A to the power 0, that is if the index is 0, the power is 0, then it is 1. A to the power 0 is 1. For example, 2 to the power 0 is 1. 3 to the power 0 is 1. Anything, any number which has index as 0 becomes 1. This is one important note. Second note is, suppose we have a to the power of minus m. Suppose you have something like this. Then you can write it as 1 by a to the power m. You can write it like this. So example, if I have 2 to the power of minus 3, example, I can write this as 1 by 2 to the power plus 3. Both of these mean the same, right? So this is a very important concept. This is another important concept. If I have something like this, how should I write it? right? I have something like this. I have a root, and I also have an index. How do I represent this? I can write this as a to the power p by q. Whatever is the root, I can write it as by q. Say for example, if I have, say I have fifth root of something like this. Fifth root of 3 square. Fifth root of 3 square. 3 square. How I can write it as? I should be writing it as 3 to the power square by this number 5. Let's take another example. Say I have something like this. Cube root. Cube root. When you have 3, you call it as cube root. Right? So if I have something like this. Say I have something like this. How do I write this? I have to write this as 2 by 3, the whole square. This 3 I'll have to divide here by 3. This 3 will become by 3. This is again a very, very important concept. Right? Let's take another example. Say we have 3 by 4. Fourth root of 3 by 4 and to the power 3. How do you write it as? You should write it as 3 by 4. Put this 3 here. Divide by 4. So this number will come in the denominator. 5 will come in the denominator. Q will come in the denominator. So let's go through a few examples, right? Using this indices concept. Let's take this first example. We have 9 by 4 to the power of minus 3 by 2. Now, we'll have to remember the first note that we went, key note. We said that a to the power minus m can be written as 1 by a to the power m. Right? Now, if I use the same note, same concept, then instead of a, I have 9 by 4 here. Right? And I have, instead of m, I have minus 3 by 2. Now, I can write this as 1 by 9 by 4 to the power 3 by 2. Right? This minus m will become plus m when it comes to the denominator. Right? Now, I can't have two denominators. I can't have two divide bys, right? I can't have two denominators. There's one denominator here, and this entire thing is also a denominator. So in this case, I'll have to take reciprocal. I have to push this 4 to the top. So it's going to become 4 by 9, right? And you'll have 3 by 2. Whenever there is double division, I'll have to take a reciprocal of the denominator. Reciprocal. That is, I have to reverse. So it will become 4 by 9. I'll basically push this 4 to the numerator. It's going to become 4 by 9. And this power is going to be retained. So this is going to be 4 by 9 to the power 3 by 2. Now I can write this as, instead of 4, I'll have to write it as 2 square. I can write 4 as 2 square. 2 into 2, 4, right? And 9 is nothing but 3 into 3 is 9, right? That is nothing but 3 to the power 2. So I can write this as 3 to the power 2. And you have 3 by 2, right? Now what I will do is, by third law, a to the power m into n, you can write it as a to the power m into n, right? Same form here, right? Same way you have. So you have 2 square, you will have to multiply this power. Similarly here, 3 square, multiply this power. Right? Now let's solve this. 2 and 2 will get cancelled. So you'll have 2 to the power 3. Here again 2 and 2 will get cancelled. You'll have 3 to the power 3. Now we can simplify. 2 3 times. 2 into 2 into 2. And this again 3 times. So this is nothing but 8. This is 27. So this is the answer. So reason we are doing this, why we are representing this like this, right? Because we can't solve this. What is 4 to the power 3 by 2? How do you solve 4 to the power 3 by 2? See, if you have 2 to the power 2, I can say 2 into 2 and say it's 4. But if I have something like this, how do I solve this? That is why we are using this particular method of simplification. Let's go through problems related to indices. First one is 5 to the power 5 to the power 0. Now, in this case, what we should do is, we have to first resolve this. We'll have to first solve this. 5 to the power 0. What is 5 to the power 0? Anything to the power 0 is 1. So we'll get 5 to the power 1 plus, again, anything to the power 0 is 1. So 5 plus 1, 6 is the answer. Let's go to the second one. Here we have 5x cube by y the whole square. So let's split this. So it has to be 5 square into x cube the whole square. Basically, for every number, we will have to put this index. You remember the property a to the power m into n. We'll have to write this as a to the power m into n. So, same property we'll have to use here. We'll have to put this power for this denominator also, because this is all square. So, we'll get y square. Now, this is nothing but 5 square is equal to 25 into, now 3 into 2, we'll have to multiply this. 3 into 2 is 6, and then y square. So, this is the answer. Now, let's solve this third one. This is a simple one. This is, remember the property, a to the power m into a to the power n is equal to a to the power m plus 1. So, this property we'll have to use. So, this is nothing but a to the power x plus y plus 2x minus y. We are adding these two powers. So, we'll get a to the power x plus 2x is 3x, y minus y is 0. Right? So, a to the power 3x is the answer. Let's go to the fourth one. So, here remember the law. You have root here. Right? This is cube root. 3 is there. So, this is of the form, when you have anything like this, when you have something like this, it's you can write this as a to the power p by q. Basically, whatever you have in the root, right, that you can put in the denominator for the power, a to the power p by q. Similarly, here we have x square, and here you have 3. So, you'll have to make it as by 3, right? Now, we'll copy the rest. Rest is 3, and then half. Now, we'll multiply this. This is of this form, a to the power m and n outside. Now, we'll multiply these powers. So, we'll get x to the power, when you multiply, this and this will get cancelled. So, you'll be left with x square and then half here. Now, again, we'll have to multiply this, right? So, it will be 2 into 1 by 2. 2 and 2 will get cancelled. So, we'll be left with x to the power 1, which is nothing but x. So, x is the answer. Let's solve this fifth one, right? Here we'll have to multiply, right? So, this is of the form, so there is a simple formula here. A plus b into a minus b is equal to a square minus b square. Basically, when you multiply this with this, and when you multiply b with a plus b, you're going to get a square minus b square. You can either remember this formula, or you can multiply 1 by 1, right? See, if I multiply this 1 by 1, x to the power half plus y to the power half into x to the power half minus y to the power half. If I multiply, I'll get like this. This one I'll multiply. This one I'll multiply with this. So I'll get x to the power half into x to the power half. Then x with this. X to the power half into y to the power half. Now, next, this one I'll take. Y with this. So I'll have x to the power half into y to the power half. And there is minus here. The next one again, minus and minus. Minus and plus is minus. So I'll get y to the power half into y to the power half. Now if I simplify this, half I'll have to add the powers, right? When you have something like this, a to the power m into a to the power m n is equal to a to the power m plus n. So I have to add the powers here. X to the power half plus half is 1 plus x to the power half into y to the power half. Now here you have minus x to the power half, y to the power half, and minus half you have to add. Half and half is 1. Now this will get cancelled. This is plus and this is minus, right? So this will get cancelled. You will get x minus y as the answer. Now this is using this multiplication. Even if I use this particular formula, I'll get the same answer. Formula is, see this, you consider this as a, this as b. Again this is a, this is b. Here you have a plus b, here you have a minus b. Now if I directly use this formula, it will be a square minus b square. That is x to the power half the whole square minus, what is b here? Y to the power half the whole square. I am using this formula. So here 2 and 2 will get cancelled. I'll get x minus y. See, in just one step I got this answer. If you remember this formula, in one step you'll get this answer. Else you'll have to do all these multiplications. Let's go through a few more problems. So as we go through, the problems will become slightly complex. So let's solve them one by one. This is the law, right? A to the power m into a to the power n is equal to a to the power m plus n. Right? Using this law, we'll have to solve this. And there is also second law, a to the power m by a to the power n is equal to a to the power m minus n. Right? Using these two laws, we'll have to solve this. So a and a, base is same. We call this as base, right? This is base and this is power. Now let's add. Bases are same, so we can add the powers. 2m plus n plus 3m plus n. We are adding here the powers by a to the power 4m plus 2n. Now let's solve this. You will get a to the power 2m plus 3m is 5m, n plus n is 2n. And similarly here we have a to the power 4m plus 2n. Now we'll have to use this law, second law. As per second law, you'll have to take this power here on top and it will become minus. So 5m plus 2n minus of 4m minus of 2n. So you'll get a to the power 5m minus 4m is m, and 2n minus 2n will get cancelled. This will get cancelled. So you'll get a to the power m. So a to the power m is the answer. So let's solve the second sum, right? Here we'll have to split this, right? Remember this, a to the power m into a to the power n is a to the power m plus n. So when you have bases same and there is multiplication, you can add the powers, right? But here we'll have to do reverse. Here it's given like this, m plus n is given. So split it like this, right? Here it is 2 to the power n plus 1. I can split it into 2 to the power n into 2 to the power 1. Reverse. I'm reversing this entire law, right? So I'll write it as n into 2 to the power 1, right? Plus, similarly here I'll split 2 to the power n into 2 to the power minus 1 by 2 to the power n plus split it 2 to the power n into 2 to the power 2. Now what I will do, I'll take common. 2 to the power n is common. So I'll be left with 2 to the power 1 plus 2 to the power minus 1 divided by, here again I can take common, right? So I'll be left with 1 plus 2 square. So this will get cancelled. I'll get 2 plus 2 to the power minus 1, right? I can write 2 to the power minus 1 as 1 by 2 to the power 1. This is that key law, right? Key property. If I have 2 to the power minus p, I can write it as 1 by 2 to the power p, right? Basically, minus p will become plus p by putting this in the denominator, right? So I can write this 2 to the power minus 1 as 1 by 2 to the power 1. Instead of minus 1, it will become plus 1, right? By 1 plus 2 square, that is 5. So this is nothing but 2 plus half. 2 plus half is, I'll take 2 as LCM. It's going to become into 2. So 4 plus 1 by 5, which is 5 by 2 by 5, which is nothing but, I can write this as 5 by 2 into 5, which is, this will get cancelled. I'll be left with half. So half is the answer. Now let's solve this fourth problem. Fourth problem, if you see all the bases are same, x, 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 everywhere the bases are same, powers are different, right? So we'll take the first one, multiply these powers. So it is of the form like this, right? A to the power m into n, right? So you should write this as m into n. Now if you have, you see this, it's of this form, right? It's of this law. So let's multiply. So you'll get a into a square, a into b, ab, right? Now similarly, this power is also for this denominator, right? This power is applicable for the denominator also because there is a bracket here. It's for the entire thing. This a plus b is for the entire thing. So now I'll multiply b into a, ab, plus b into b, b square. Now we'll go to the next one. Same thing, we'll multiply b into b, b square, b into c plus bc. Similarly here we'll have to multiply, right? C into b, bc, c into c, c square. Then go to the third one, c into c, c square, c into a, ac. Then again multiply these powers, a into c, ac, a into a square. So now let's use this particular division law, right? This is multiplication law, this is division law, right? We'll use this division law. A to the power m by a to the power n is a to the power m minus n. Basically, you take this denominator power to the top. You take n to the top and subtract it, right? So now I'll take this to the top and subtract. So I'll get x a square plus ab minus b square. Now I'll do the same thing with the second term also. B square plus bc. I'll take this on top. Minus bc minus c square. Then third one is, we'll take this on top. So you will get c square plus ac minus a square. Now we'll see something will get cancelled. AB and AB will get cancelled. Plus BC minus BC plus AC minus AC. So we'll be left with A square minus B square into B square minus C square into C square minus A square. Now we'll have to use this second law. Right? As per second law, you have the same basis. This is multiplication law, right? You have the same basis. So we'll add the powers. We'll have to add all these powers. So we'll get x to the power a square minus b square plus b square minus c square plus c square minus a square. So what we will get? We'll get minus b square plus b square will get cancelled. Minus c square plus c square plus a square minus a square. So basically we will have 0. We'll be left with x to the power 0. Anything to the power 0 is 1. So this is the answer. Now let's solve the fifth one. So here you have 2, 8, 16. Bases are different. If we have to simplify, we'll have to make the bases same, right? So we'll get all of this in the form of 2. We'll use 2 here, 2 here. So that if the bases are same, then you can use the laws and simplify it. So what we'll do is, instead of 8, we can write 2 cube. 2 cube is nothing but 2 into 2. 2 to the 4, 4 to the 8. So you can write this. So you can write as 2 cube. This is 8. And then we'll have to copy this. 2a minus b. Similarly, instead of 16, we can write 2 to the power 4. That is 2 into 2 into 2 into 2. So 4 to the 8, 8 to the 16. So you can write it as 2 to the power 4 to the power a plus b. So let's not forget this power. Now, let's remember the law always. A to the power m into a to the power n is a to the power m plus 1. Multiplication law. If I use the division law, it will be m minus n. And this one, when you have brackets, you'll have to multiply the powers. So now using, let's first multiply this. We'll have to use this law, multiply this. So 2 to the power 7b minus 2a, 3 into 2, 6a, 3 into b minus 3b. Similarly, we'll do for the denominator, 4 into a, 4a, 4 into b, 4b. Now let's use this addition here, right? Let's use this particular law, multiplication, right? Bases are same and there is multiplication here. So we'll have to add the powers. So we'll get 2 to the power 7b plus 6a minus 2a minus 3b. And we have the denominator, which is 4a plus 4b. Now we'll use this particular law, division law. The bases are same, 2 and 2. So we'll subtract the powers. We'll take this on top. So we'll have to subtract. We'll get 7b plus 6a minus 2a minus 3b. Now minus 4a and minus 4b. So we'll get 2 to the power 7b minus 3b is 4b. 4b minus 4b is going to become 0. Next 6a minus 2a is 4a. 4a minus 4a is 0. So ultimately we're going to get 0 here, which means 1. 1 is the answer. With this video, we have come to the end of this particular topic. Thanks for watching. Hope this video was useful.